So, very good morning. This is Yog Raja from Hindustan College of Engineering and Technology. So, I am working as assistant professor in the Department of Automobile Engineering. So, today we will discuss about the emissions from the electric vehicle and conventional engines. So, we may compare the emission levels. So, especially in the automotive emission and pollution control subjects, we have focusing on the emission level and how to compare and how to control the emission level, and at the same time, so which one is the less amount of emission takes place. So obviously the electric vehicle is the less pollution compared to conventional engine, but we cannot say that 100% emission reduction takes place in the electric vehicle. So let's move to the, so we know that the symbols of vehicles. So first one is we have battery electric vehicle. So that is simply in the short form we can say that BEV, that is 100% electrically operated. That is the design of the vehicle. The second one is we have in the blue color, we have the plug-in hybrid electric vehicle. That is the combination of electric and internal combustion engines. So the last one, third one is the conventional vehicle. That means IC engines, 100% internal combustion engines. So that is the design or symbol of the particular vehicle. And coming to the electric vehicles, so nowadays all over the world are moving to the electric vehicles. We know that conventional fuels having the more amount of pollutions, and again the fuel also, fossil fuel also almost exhausted. So that is this is the time to move to the another option. So in all over the world, initially they have taken electric vehicles, so that being seen as the future of mobility, that is electric vehicle, and governments also across the globe are pushing battery run cars to reduce air pollution in main cities. And however, the increased focus on electric vehicles has also brought some environmental and friendly aspects of these battery run cars to the fore. And again, there is a section that even believes that electric vehicles cause more damage to the environment than internal combustion engine powered cars. So we have so many things are available. So electric vehicle and conventional vehicle. So, and again, in terms of life cycle emissions, are the total amount of greenhouse gases emitted throughout a product's existence, including its production, usage and disposal. So that is the life cycle emissions. So how much amount of pollutions takes place, greenhouse gases are emitted from manufacturing to the disposal of the vehicle. And again, to compare these emissions effectively, a standardized unit called metric tons of carbon dioxide equivalent is used. In the short form we can say that TCO2e, that is metric ton of CO2, that means carbon dioxide emissions in terms of metric ton. So which accounts for different types of greenhouse gases and their global warming potential. So here in few things we discussed in the 2021 life cycle emissions of medium sized electric vehicle, hybrid vehicle and internal combustion engine, each stage of their life cycles using ton of carbon dioxide emissions. These numbers consider a use phase of 16 years and a distance of 2,40,000 km, that is considered. So you can see that the life cycle emissions of electric vehicle and combustion engine vehicles, that is a small comparison. In 2021 some analysis takes place. You can see that the first one battery electric vehicle, and second one hybrid electric vehicle, third one internal combustion engine vehicle. So you can see that the production emissions. So initially we have, when we are manufacturing the vehicle. In the battery electric vehicle, we have the battery manufacturing, then vehicle manufacturing. So you have almost 14 metric ton of CO2 emission takes place. But in coming to the hybrid electric vehicle, you have only one during battery manufacturing and 9 in the vehicle manufacturing. But coming to the IC engine, internal combustion engine vehicle, there is no carbon dioxide emissions in the battery. There is no chances for the battery manufacturing. Only we are focusing on vehicle manufacturing only. So we have almost 40% higher than the hybrid and combustion engine vehicles. So the battery electric vehicle give the some more emissions in during the manufacturing point of view. You can see that only 14 metric ton of CO2 emissions, but in the hybrid electric vehicles only 10 metric ton of carbon dioxide emissions, but in the IC engine vehicles only 10 metric ton of carbon dioxide emissions. That is the protection emissions, we can say that. So coming to the in the second stage, so electricity production, fuel or electricity production, that is the usage. When we are use phase emissions, that is also in terms of metric ton carbon dioxide emissions. So we have fuel and electricity productions. So in the battery electric vehicle, you can say that almost 26 metric ton of carbon dioxide emissions, because we need electricity. And again, tailpipe emissions are 0, maintenance is almost only 1. But in the hybrid electric vehicle, we have the fuel or electricity production, we have only the 12, and the tailpipe emissions are 24, maintenance are 2. But in the IC engine, internal combustion engine vehicle, so we have the fuel production is 13 ton of carbon dioxide emissions, and tailpipe emissions is 32. That is 0 in the battery electric vehicle, and maintenance also 2. So that is a difference. You can say that in the fuel or electricity production and maintenance is almost only 27 metric ton of carbon dioxide emissions, but coming to the hybrid electric vehicle, that is almost 24 plus 12 plus 2, 24, 26, 36, 38 almost. So we have 38 metric ton of carbon dioxide emissions, here only 27. But coming to the IC engines, we have 13 fuel production, tailpipe emissions are 32, maintenance are 2. So we have 47 metric ton of carbon dioxide emissions. So that is the difference here. And again, end of life. So we have the post consumer emissions, end of life. So we have, there's no huge variations in that post consumer emissions. So totally we can combine that how much amount of emissions takes place in the battery electric vehicle, 39 metric ton of CO2 emissions, and 47 in terms of hybrid electric vehicle. But IC engine is 55, that is 55 metric ton of carbon dioxide emissions. So this is sample taken by some organizations. So that is 16 years. So this calculation they are taken for life cycle is 16 years, and total kilometers 2,40,000 kilometers. So based on that, some emissions are reduced in the battery electric vehicle. So we can compare all those things. So compare these three. Battery electric vehicle is somewhat better than hybrid and IC engines. So then electric cars found to cut emissions drastically. So this is another statistics. So source ICCT, that is estimated reduction in life cycle greenhouse gas emissions of new medium size electric cars compared to the gasoline cars. So here it is, this first one is the cars registered in 2021, in 2030 cars registered in 2020. In the European countries, you can say that minus 66% and 74% in terms of 2030, and United States, that means 60%, that goes to the 62%. But in the China, 37% emissions and again reduction takes place 48% in 2030, same as in India 19 to 30%. So that is another important things compared with electric vehicle. And again the electric vehicle also considering tank to tank wheel emissions and energy ecological efficiency. So first one is, you can see that materials and methods. So one vehicle for hybrid electric vehicle, plug-in hybrid electric vehicle, and plug-in electric vehicle categories, simulation of fossil fuels and biofuels combustion, so that particular symbol. So tank to wheel emissions evaluated considering the Brazilian electricity mix. So according to that the calculations takes place. So we can say that highest values of tank to wheel emissions were found for the plug-in hybrid electric vehicle. So then PEV was the best choice to the Brazilian scenario when the emissions were considered. And again, so this for electricity protection, considering the infrastructure and the use of biofuels, the hybrid electric vehicle in dual fuel mode is the most appropriate choice. And so this one is the highest value of energy ecological efficiency was found for the engine in dual fuel code. So that is also we can for flexi fuel type of vehicles that may be available in some of the countries, that is also to reduce the emission levels. And again the carbon dioxide emissions, equivalent life cycle emissions from commercially available passenger cars. We can see that the protection emissions, so already we discussed protection emissions, body and batteries, utilization emissions, fuel and electricity, recycling emissions, that is recycling and disposal, database with 790 commercially available vehicle models, and finally we have evaluation and comparison of different powertrains and energy sources. You can see that the relative reduction of total life cycle emissions. So we can say that the gasoline is almost 0% with reference. So you can see here in the blue color the production emissions, green color recycling emissions, and orange color utilization emissions. So yellow color is the total emissions. So you can see here the different manufacturer having the different emission levels. So from first one is the Volkswagen, second one is the Mercedes Benz, and next one is the Audi, then Toyota Mirai. So all those things we have different things are available. So different vehicles. So first one is the gasoline, we have almost 49.6, then diesel 38.5, then CNG compressed natural gas 26.8, and then hydrogen based, that is a Toyota Mirage 19.7, and coming to the gasoline plus electricity, that is 13.2, Mercedes Benz diesel and electricity 31.2, and again Tesla model, that is 17.5, again Tesla model only electricity 5.5. So then the right side we have total life cycle emissions can be reduced by up to 89% through vehicle electrification. Then renewable fuels and energy leads to the lowest life cycle emissions. Then the total life cycle emissions increase relative to vehicle curb weight and peak motor power. So that is a few things about the comparison of electric vehicle and conventional IC engines. Thank you.